Okay, today we're going to be looking at our introduction to geometry. So as we go into the next two modules, we're going to be looking more at shapes. So today we're going to make sure we know our vocabulary. So to get us started, our goal for today is identify and apply geometry terms and relationships. So the first one we're looking at is congruent angles. Congruent angles are angles that are the same size. We often mark things that are congruent with a little equals, a little line on top. Okay, a right angle means that it's an angle that is 90 degrees. So then to go along with that is if I tell you you have perpendicular lines, that means they're going to form a right angle. And sometimes they note that with they'll say line AB, and to indicate a line they just put a little line on top of the two letters. And they'll actually do this little upside down T to represent it's perpendicular to, let's say, CD. Once again, a little line on the top means that it's just a line segment. If you have something that has a little arrow, that means it's a ray, so it's got an endpoint on one side and an arrow on the other. Okay, complementary angles are angles that add to 90 degrees, whereas supplementary angles are angles that add to 180 degrees. I usually think about complementary, C comes before S in the S alphabet, so therefore that's got to be the smaller one. So that's the 90, supplementary is 180. A specific type of supplementary angles is if they are a linear pair. So it's two angles, right? A pair is two that form a straight line. So it means that the two angles have to be what we call adjacent. They got to be side by side. So one angle's here, the other angle's on the other side, and they form a straight line. So they will add up to 180. But they've got to be right next to each other. So maybe I should put that, two adjacent angles. Okay, when you see this little M in front of, this represents angle A. That little sign is not a less than. This just means the measure of angle A. So if I wanted to know, hey, the measure of that angle is actually 5 degrees or something like that. We also see the word bisect a lot. Bisect means to split into two equal parts. And last but not least, the triangle sum theorem. So if you think about a triangle, this is adding the angles. So when you add, or maybe I'll say the angles in a triangle add to 180. I think it's interesting to notice there, we don't necessarily call those usually supplementary, because usually with supplementary we're just talking about two angles. But yeah, so we have three angles in a triangle. Okay, so now let's apply that knowledge. So, as with this first one, it says, what's the relationship between angle ABC and CBE? So first of all, trace from A to B to C. They're talking about this angle over here on the left, and then C to B to E. I decided there's something about those two angles. These angles are across from each other, so they are congruent, meaning they have the same size, and we call them vertical angles. Vertical angles are angles that are across from each other. So when you got two lines that intersect, they're the ones that are across from each other. And then in this case, if they are congruent, we can set those two angles equal to each other. So 18 equals x squared plus 2x plus 10. And we're going to solve for x. Hopefully this looks familiar from your last unit. So we're going to set it equal to 0. 0 equals x squared plus 2x minus 8. So what multiplies to a negative 8 and adds to 2? Positive 4 and negative 2. So in factored form, this is x plus 4, x minus 2. But then as you solve and you set x plus 4 equal to 0, and you subtract 4 from both sides, you actually get x equals a negative 4. And as you set x equals 2 equal to 0, and you add 2 to both sides, you get x equals a positive 2. Okay, let's go to the next one. ABD, so talking about this angle over here on the left, and DBC, they're talking about this angle over here on the right. In this case, we do not know, and even in the picture they don't look, they're congruent. So usually we mark an angle, like different angles with just one extra dash, unless they are the same size. In this case, we want to know what's true about these. In this case, they're forming that straight line, so we call them a linear pair. Which means, right, that they add to 180. Maybe I should have put up here that they're congruent. Okay, so if I label CBD as 7x squared and ABD as 11x squared, it's saying the 11x squared plus 7x squared equals 180. If we combine our like terms, we get 18x squared equals 180. There's a couple different ways you could solve this, but I'm going to go for the square root because there's just an x squared term. So I'm going to divide both sides by 18. X squared equals 100. Take the square root of both sides. X equals positive or negative 10. Notice here that it wants us to find the measure of angle ABD. And we know that's 11x squared. But if we know x is 10 or negative 10, when you square 10 or negative 10, we get 100. So 11 times 100 equals 1100. Alrighty then. Okay. So this doesn't quite make sense in that picture. But that's what the algebra tells us. That's a really big angle. Okay. On this next one, we want to find the measure of angle A. So first of all, you gotta look at this and say, okay, there's 3 angles here. We got a triangle. So all 3 of those angles, when I add them up, so 3x plus 10 plus 60 plus 8x equals 180. Right, because a triangle adds up to 180 degrees. So 3x plus 10 plus 60 plus 8x equals 180. Combine your like terms, so we get 11x plus 70 equals 180. Subtract 70 from both sides. 11x equals 110. Divide both sides by 11. X equals 10. So this time, if you're finding the measure of angle A, we're going to do 3 times x is 10 plus 10. So we get 30 plus 10. So the measure of that angle is actually 40 degrees. Which in this case, that makes sense, right? It's up less than 180. Okay. Now we're going to do some drawing and labeling to make sure we understand how the diagrams work. We just practiced some algebra. It said, find the supplement of a given angle. Then draw the 2 angles as a linear pairs. Label each angle with its measure. So here it says JMS is 72 degrees. So let's say, okay, it's got to be less than a right angle. If I call it JMS, and this is 72 degrees, we want something that makes a linear pair with it. So that means it's going to form a straight line. And it says B is the other vertex. Vertex usually represents actually this middle part of it. So maybe they want this to be, sorry, I probably should have said M as the vertex. But maybe let's make B the other side of it. If we want to find what is its supplement, we want it to add up to 180. So 180 minus 72 equals 108. So this other angle has to be 108 degrees. And as you notice, they do make that straight line, which means that they're supplementary. Okay, we want to find x over here. So we got more information about this triangle over here on the right. So let's start over here. If I know that this has to be 180, if I take 180 minus 83 minus 35, I should be able to find that other angle, right? So 180 minus 83 minus 35 is equal to 62. And if this is 62, when these two lines intersect, exactly across from that is also 62 degrees. The only tricky thing here is, I don't know, it depends how much you remember about geometry. But here, since we got what they call an isosceles triangle, the two sides are equal, these two angles in the bottom are also equal. So if I do 180 minus 62, I end up with 118. And both of these two angles, if that's x, this is also x. So I've got two x's that have to equal 118. So as I divide that by 2, I end up with x is equal to 59. So each of those angles at the bottom would have to be 59, because 59 plus 59 plus 62 is what gives me 180 degrees for that second triangle. Okay, what do you know about the sides or angles of the given diagram? Okay, one word of caution you gotta be really careful about in geometry, unless it is something you stated. So unless it's something like, hey, I tell you the lines are perpendicular, right? Or you can see that they make a linear pair, right? Or I tell you that they're bisected, or you can tell that they're vertical angles. Unless you can come back to some geometry, don't just mark things because they look like they're congruent. So here I could say these two central angles are congruent because of vertical angles. So if I want to label this, I could call it VQW. Angle VQW is congruent to angle, let's say SQR. And that would be because of vertical angles. Excuse me. But as far as the rest of the diagram, even though these two lines may look like they're parallel, you can't just assume that. They look like they're the same. You can't just mark it. It's got to have a reason. So in this case, that's actually all we know about the diagram. Whereas if I give you a statement like, hey, triangle CBD is congruent to triangle CUT, then I can say lots of things about it, right? Like, hey, for example, angle C is congruent to angle C, right? So the two central angles, because they're vertical angles as well, are congruent. Angle D in the middle is congruent to angle U, and usually we use two sets there, right, of arches, because it's different from the first angle. And last but not least, B is congruent to T. As we mark sides, look at the same position. So CD is congruent to CU. Usually we do one dash for the first set, and then for the next set, let's say DB, we'll do 2, and UT can also have 2. To sort of show that they're separate from the other side. And then last but not least, this third side is congruent to this third side. So pay attention to those markings and just be careful about what you do. Next time we'll get into proofs, so you'll kind of want to be familiar with this terminology. Good luck with the